I'm Chris, and in this lesson we're going to take a look at an SAT math question and a strategy for answering it called picking numbers. The acronym being PAM. It's something that at Sanderson Test Prep we use a lot. You may have seen some of our other videos which introduce it, but this happens to be one of my personal favorite examples of how this works with a really tough math question. We're going to go through this question and we're going to do two versions of it. We're going to take a look at how this would be done with picking numbers, and then we're going to take a look at how it would be done algebraically, just so we can see the real value in picking numbers in terms of coming up with an answer quickly and accurately, and not having to deal with as much messy algebra. Holidays are upon us, so we're going to use green and red for our colors for the two versions of this particular question. So let's take a look. If you're following along in your official SAT study guide, it's that big blue book. This is on page 485. It's question number 13. And it says, if n is a positive integer and 2 to the n plus 2 to the n plus 1 equals k, what is 2 to the n plus 2 in terms of k? So already this sounds a little bit complex algebraically. So let's take a look at how we can use picking numbers to help simplify things here. So if we look, we see that we have n and k as our variables. So with n and k as our variables, we want to go ahead and start by picking numbers. So let's try something for n. And when you go to pick numbers, you just want to try to make sure the math that you have to do is not too complicated. So if we look here, if we pick a value for n, if I picked something like 15, well then this would be 2 to the 15th plus 2 to the 16th. And I don't know off the top of my head what that is, but I do know that if I plug that into a calculator to solve it, it's going to be a gigantic number, something that I don't really want to work with if I can help it. So let's pick something nice and small for n. I also want to avoid negatives on this problem because negative exponents are going to give me fractions, and that's a little bit cumbersome to work with. So let's try something like n equals 1 or n equals 2 and see how this works. We'll go with n equals 2. So if we pick n equals 2, let's solve and see what k would equal. So when you plug that in, 2 squared plus, that would be 2 to the 3rd, and that's 4 plus 8, which would give us 12 for k. So when you plug in a 2 for n, you get k equals 12. So now we're done with the picking numbers portion of our question. We pick, then we answer. Our acronym PAM, P-A-M, pick, answer, match. So now we're going to answer the question that we're being asked. We're being asked, what is the value of 2 to the n plus 2? And it has this phrase here, in terms of k. That's another reason we really like picking numbers, because we don't have to worry about in terms of k. That just means there will be variables in the answer choices. But in this case, we can go ahead and just solve it numerically, because we're going to get an actual concrete answer since we're plugging in numbers instead of variables. So here, 2 to the n plus 2, when we go to answer that, we're plugging in 2 for n. So that would be 2 to the 2 plus 2, which is 2 to the 4th, which is 16. And that's our answer to the question. Now, in order to find which answer choice that matches up with, we're going to match. And we're going to evaluate answer choices A, B, C, D, and E, plugging it in for all 5. In this case, just in the interest of time, we're going to go ahead and just plug it into the correct answer choice. The correct answer choice on this question is answer choice B, 4k over 3. And I just want to show you how that works. So we got 12 for k, and that's what we're going to be plugging in. And we're trying to get the answer of 16, because that's what we got when we actually answered the question they were asking. So we picked, we answered, now we're going to match. And for answer choice B, when you plug in 12 for k, you get 4 times 12 divided by 3, which gives you 16 as your result. And that matches the number that we came up with as our answer. So therefore, we know that answer choice B is the correct answer to this question. So if you understood that part of it and you understand picking numbers and know how to do PAM, P-A-M, then you can go ahead and move on to some of our other videos, links shown here. If you want to really see the value in this process, then take a quick look at how this would be solved algebraically. It's much more challenging to do it algebraically, and it's a good little exercise mathematically if you want to really challenge yourself. But on the SAT, I want us to appreciate why this might not be the best method or the best question to approach algebraically. Let's take a look at how complex this would be. 2 to the n plus 2 to the n plus 1 equals k. So what we would have to do is we'd have to split this up. An exponent that's being added is the same thing as two separate terms with the same base being multiplied. So this would be the same as saying 2 to the n plus 2 to the n times 2 to the 1 equals k. Between these two terms, we could factor out a 2 to the n, which would give us 2 to the n times 1 plus, when you factor out a 2 to the n here, you're just left with 2 equals k. When you simplify that, you get 2 to the n times 3 equals k. And when you solve for 2 to the n, we get k over 3. Really complex math, even having gone through this several times before, it still takes me a while to write it out. So it's going to take even longer if this is our first time seeing this question and we have to look at it and kind of think about it for a few minutes and figure out what exactly we're supposed to do to try to solve algebraically. And if you notice, we're still not even quite done with the problem. Now we would have to plug this value back in to what they're asking for, 2 to the n plus 2. That would be like saying 2 to the n times 2 squared, which is equivalent to 2 to the n times 4. And if we plug in k over 3 in place of 2 to the n using substitution here, then we get k over 3 times 4, which would give us 4k over 3 as our answer. So either approach gets you the correct answer, but as far as what you're actually going to do on your SAT, and what's really important to understand here is think about the timing on test day. So here, in solving this, we really only had to write down very little. We wrote down n equals 2, k equals 12. A lot of this is probably even math that you could do in your head. We got 16, and then we found our correct answer choice. Over here, we had to write out 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of calculations in order to arrive at the correct answer choice. It took much longer to do algebraically, and it really opens the door for the potential of making a careless mistake. So on your SAT, we want to use that Sanderson test prep strategy of picking numbers in order to make an extremely difficult math question much, much, much more manageable. For more, please feel free to take a look at our other videos or check out our website. Thanks for watching.